Take a look at your morning coffee. See that foam on top? Those tiny bubbles dancing on the surface? What if I told you that each one of those bubbles might contain the same mathematical structure as the cosmic wormholes that could theoretically connect distant galaxies? What if the universe's most exotic phenomena aren't hiding in the depths of space, but right there in your kitchen, operating at scales so small we never notice them? What if wormholes aren't just science fiction? They're as common as coffee foam, the shape of space itself. Before we dive into your coffee cup, we need to talk about something that sounds abstract but is surprisingly concrete: the shape of space. Most of us think of space as empty, a void where things happen. But Einstein showed us that space is more like a fabric that can be stretched, twisted, and folded. Imagine spacetime as a giant sheet of rubber. Massive objects like stars and planets create dips and curves in this sheet. Now imagine taking that sheet and folding it so that two distant points touch. Poke a hole through where they meet, and you've just created a wormhole, a shortcut through spacetime that connects distant regions of the universe. This isn't just mathematical poetry. The equations of general relativity predict that these cosmic shortcuts could exist. They're called Einstein-Rosen bridges, and they represent one of the most mind-bending possibilities in physics: tunnels through spacetime itself. But here's where it gets really interesting. The mathematics that describes these cosmic wormholes doesn't care about scale. The same equations that predict galactic shortcuts also predict that tiny wormholes could exist everywhere, including in the foam of your coffee. The quantum foam revolution. At the smallest scales imaginable, about 10 to the power of -35 meters, a scale called the Planck length, space itself becomes foamy. This isn't a metaphor. According to quantum mechanics, spacetime at this scale is a bubbling, frothing sea of virtual particles and fluctuating geometry. Picture zooming into your coffee foam with the most powerful microscope imaginable. First, you'd see the bubbles. Zoom in more, and you'd see molecules. Keep zooming through atoms, through subatomic particles, through quarks, and finally, if you could zoom in 20 orders of magnitude beyond that, you'd reach the quantum foam. At this scale, spacetime doesn't look smooth anymore. It looks exactly like foam, with tiny bubbles constantly forming and disappearing, connections appearing and vanishing, and yes, tiny wormholes opening and closing in the span of time so brief that they make a nanosecond seem like an eternity. These aren't theoretical wormholes. They're predicted by our best theories of quantum gravity. They're called quantum wormholes or baby wormholes, and they might be everywhere: in your coffee, in your phone, in your hand, in the air you breathe. Topology, the mathematics of holes. To understand how wormholes could hide in coffee foam, we need to think like mathematicians who study topology, the science of shapes and connections. Topologists don't care about size or exact measurements. They care about fundamental properties. How many holes does something have? How are different parts connected? In topology, a coffee cup and a donut are the same thing. They both have exactly one hole. The hole through the handle becomes the hole through the donut. Now apply this thinking to spacetime. A wormhole is topologically just a handle connecting two different regions of space. And just like your coffee cup has a handle at the human scale, spacetime might have handles, wormholes, at the quantum scale. The beautiful thing about topology is that these connections don't depend on size. A wormhole connecting two galaxies and a quantum wormhole in your coffee foam have the same topological structure. One is just vastly smaller than the other. The coffee cup connection. So why coffee foam specifically? It turns out that foam is one of nature's most sophisticated geometric structures. Each bubble in foam naturally forms the shape that minimizes surface area while maximizing volume. A mathematical optimization that creates complex topological structures. When you look at coffee foam, you're seeing a natural computer solving geometric equations in real time. The bubbles arrange themselves according to mathematical principles that mirror the same physics governing spacetime curvature. The process that creates coffee foam, tiny gas bubbles forming and connecting in liquid, might actually be a macroscopic analogy for how quantum wormholes form in spacetime foam. Both involve bubbles, both involve connections forming between separate regions, and both follow optimization principles that create stable structures. Recent research in quantum gravity suggests that spacetime itself might be emergent, built up from more fundamental connections at the quantum scale, much like how foam emerges from the collective behavior of countless tiny bubbles. Quantum wormholes, the microscopic reality. Let's get specific about these quantum wormholes. According to quantum field theory, Pairs of particles are constantly appearing and disappearing throughout empty space. These virtual particles exist for incredibly brief moments before annihilating each other. But in the presence of strong gravitational fields or high energy densities, these quantum fluctuations can become real. Some theories suggest that among these fluctuations are tiny wormholes, microscopic tunnels through spacetime that exist for fractions of a second before disappearing. These quantum wormholes wouldn't be big enough to send messages or travel through. They exist at the Planck scale, which is to an atom what an atom is to a baseball. But they might play a crucial role in how information moves through the universe at the most fundamental level. Some physicists even speculate that quantum entanglement, the spooky action at a distance that Einstein famously disliked, might actually work through networks of these microscopic wormholes. When two particles are entangled, they might be connected by quantum wormholes that allow instantaneous information transfer. The bigger picture. The idea that wormholes might be hiding in coffee foam isn't just whimsical speculation. It's a reflection of one of the deepest insights in modern physics. The universe operates on the same mathematical principles at every scale. The topology that governs your coffee foam is the same topology that might govern cosmic wormholes. The quantum mechanics that creates virtual particles in empty space is the same quantum mechanics that powers your computer. The geometry that optimizes bubble arrangements in foam is the same geometry that describes the curvature of spacetime around black holes. This suggests something profound. There might be no fundamental separation between the cosmic and the mundane, between the exotic and the everyday. The universe might be unified not just by common physical laws, but by common mathematical structures that manifest at every level of reality. If quantum wormholes really do exist everywhere, they might mean that every action you take, including stirring your coffee, has subtle effects that propagate through these microscopic tunnels to distant parts of the universe. The butterfly effect suggests that small changes can have large consequences. If quantum wormholes connect different regions of spacetime, then your coffee stirring might influence quantum events in distant galaxies through networks of microscopic wormholes. The coffee challenge. So here's your challenge. The next time you have a cup of coffee, take a moment to really look at the foam. Notice the intricate patterns, the way bubbles connect and separate, the complex geometry that emerges from simple physics. Remember that you're looking at a structure that shares mathematical DNA with the universe's most exotic phenomena. Each bubble represents the same topological principles that govern black holes, wormholes, and the fundamental fabric of spacetime itself. Try this experiment. Stir your coffee slowly and watch how the foam patterns change. You're witnessing topology in action, connections forming and breaking, handles appearing and disappearing, complex geometry emerging from simple motion. Now imagine scaling this down by 35 orders of magnitude. At that scale, similar processes might be creating and destroying microscopic tunnels through spacetime itself. Your coffee foam becomes a macroscopic window into the quantum foam that might underlie all of reality. The question that changes morning coffee forever. So the next time someone asks you what's in your coffee, you might want to mention that, along with caffeine and antioxidants, it might contain microscopic tunnels to distant galaxies, quantum connections to parallel universes, and topological structures that encode the fundamental geometry of spacetime itself. Are wormholes hiding in your coffee cup? The mathematics says maybe. Physics says possibly. And the universe, with its infinite capacity to surprise us, says we should keep looking. What if the most profound mysteries of the cosmos aren't light years away, but right there on your kitchen table, waiting to be discovered in the foam of your morning coffee? Share your thoughts in the comments below. Until next time, see you.